Greetings and salutations, everyone. This is Carl Seward, professor of mathematics and statistics here at the Arizona College of Nursing Falls Church campus. And this problem, I think, is the hardest one of the midterm exam review study guide because it's actually a two-parter. It's a little deceiving. Let's get at it. The problem reads, a population exists with a population mean of 12 and a population standard deviation of 1.5. Okay, mean, standard deviation, so there's a normal curve somewhere. I take a random sample of 36 items. Oop, there's an element there, there's an item there, and find the sample mean to be 12.5. What is the z-score corresponding to the value? So in this problem, it feels like you have too much information because you have the mean, you have the standard deviation, you have a data point, but you actually have a sample mean of 12.5. So that means we need to do something else. So let's take into account what we have. We have a population mean, let's call that mu of 12. We have a population standard deviation, lowercase sigma, of 1.5. We have a sample size, I'm going to just call that X, of 36. And then we have a sample mean, X bar, is going to be 12.5. So, because we're dealing with a sample mean, when you have all of this information, a population mean, population standard deviation, sample size, and then a sample mean, when you have those four pieces of information, you need to find the standard error. And SE is going to be the abbreviation for the standard error. And then after you find the standard error, I'm going to use that formula uh, to find my z-score. So let's find the standard error first. The standard error formula is going to be the population standard deviation, divided by the square root of the sample size. Again, that's the formula for standard deviation. This may be a little bit more familiar. Population standard deviation divided by the square root of the sample size n. And when I do that, I know that the standard deviation was 1.5 divided by the square root of 36. It just so happens that the square root of 36 is 6. So 1.5 divided by 6 in your calculator is 0.25. So I know that my standard error is 0.25. Now what I can do, and I'm going to see if I can change the color here. Let's see if I can do that. Let's see if my computer is going to let me be great. Will they let me be great? No. They're not going to let me be great. Not today. So I want to make sure it's showing up right on the screen. I think I zoomed into, okay, here we go. So let me just expand this. So next, what I'm going to do is now, comma, find the z-score. And anytime you calculate the standard error, you're going to use the formula z is equal to x minus the population mean mu. That's familiar. Divided by not the population deviation, but the standard error. And why the standard error? Because it snuck in that sample mean. If it didn't sneak in that sample mean, I'd kind of be good to go. But once it snuck in that sample mean, I knew that sample size N36 was not an X data point. It was really like an n data point. So I said, yeah, sample standard deviation. Or just think of it like this: sample mean and a population mean and a population deviation. Standard error, then the z-score. And again, the standard deviation, population deviation is going to be replaced by the standard error. So that means the z-score would be 12.5, which is my x, minus 12, which is my mu, divided by the standard error, which is 0.25. And when you do that, you're going to get 12.5 minus 12 is 0.5, 0.5 multiple divided by 0.25. When you put that in your calculator, you actually get the number 2. So the z-score would be 2 in this problem. Again, I want to just clarify the standard error tells us how much sample mean usually varies from the population mean. So we're looking for that variance. And the sample mean will vary by 0.25 from our problem. And that's we were able to find the z-score of 2. What does that mean? That means that the sample mean of 12.5 is 2 standard errors above the population mean. Another way to think about it is it's noticeably higher, but still within the range of what we would occur or what could occur by chance. Again, anything outside of 2.5, that might be not likely. I know that felt heavy, but remember standard error first and then z-score. I'm going to support you with this problem. So please feel free to see the video again for the explanation. But again, the big giveaway in this problem is population mean, population standard deviation, sample size, sample mean, standard error, then the modified the z-score formula. All right, that's it. That's all.